Welcome back. This is part two for our semi-log sessions in which we are working on learning how to graph this from our part one paper, our part one data here. So first, let's get into setting up this semi-log graph paper. So if you notice, it is a repeating pattern. It is not the same as normal graph paper. It is semi-log, which is like half normal, half logarithm. Our x-axis from left to right is no different than any graph you've been doing to this point. If you notice, no matter where you're looking across at, the width of the boxes of the grid stays the same. So our values are just like normal. So when we're setting this up, we're just going to set up like we do any other graph. We got to get to 6.5 centimeters, which we got plenty of room to go up to 7 if we go 1 millimeter per box. So 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9. 10 millimeters is 1 centimeter. So 1 centimeter, 2 centimeter, 3 centimeters, 4, 5, 6, and 7. And we're going to title this migration distance. And we'll make sure we put our unit here, which is centimeters. So there's 10 boxes between each one of these. There's no weird pattern, nothing new here. Each one of the boxes represents a 1/10 of a centimeter, which is 1 millimeter. So that there's nothing new there, nothing crazy. Now we start looking up as we go up. And what we see is that our boxes start kind of tall, and they get smaller as we go through here. And now they get a little bit bigger, and then they get back small again. And this pattern repeats itself. So this pattern repeats itself 3 times. So here, and then we'll take that pattern, and you can put it here, right? And then you can take that pattern and put it here. So it repeats 3 times. So let's focus really on this first pattern here, not the rest, as we figure out what's going on. So we're going to start at 100 base pairs. This side of our graph is going to be fragment size and base pairs. Right? Remember, base pairs is how many A's and T's, G's and C's, C's and G's there are. So this fragment here is for base pairs in length. That's what we're talking about on this side. And this first section, we're going to cap out at 1,000 base pairs. If we're doing a typical graph, the midway point between 100 and 1,000 would be somewhere, right in here, dead between 100 and 1,000. But for our logarithmic side of this graph, our halfway point is going to be at the reset here. So our boxes get smaller, 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 and then it kind of resets here to a little bit bigger box before getting smaller again. At this little reset of the size of the boxes, this is our halfway point. The halfway point between 100 and 1,000 is 500. So the scale here for the first half is different than the scale here. The scale for our first half, right, so from this section here, we're going up by tens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 110, 120, 130, 140, 150, 160, 170, 180, 190, and 200. And you can kind of usually make out, so our next little darkened line is here. So there's 10 spaces up to 300. So we would go 210, 220, 230, 240, 250, up to 300. We'd go up 10 more spots to get to 400, and then 10 more spots to get to 500. So each of these has a value of 10. This section, the next section, plays by a little bit different scale, a little bit different rules. So this is going to be half as many boxes. So there was 10 here. Now there's going to be 1, 2, 3, 4, 5 to the next section. 1, 2, 3, 4, 5, 5. So there's 5 boxes between each section now. So we halved our amount of lines between the numbers, but we're still going from 500 to 600, 600 to 700, 700 to 800, 800 to 900. Now each box, to get from 500 to 600 in 5 spaces, now we're dealing with 20s. So the next line up after 500 is 520, then 540, 560, 580, 600, 620, 640, 660, 680, 700. So that is our pattern. And this pattern is going to repeat, except we're going to go up by a power of 10. And that's why this kind of gets logarithmic. So same principle is going to apply here, right? We're just going up by a power of 10. So let's focus in on our next section. We have the same pattern we did here, but now instead of starting at 100, we are starting at 1,000. So we're going to go up by a power of 10, which means we're going to end this section here at 10,000. So our spots are the same. We still have different scales for this part and this part, but it's the same pattern as this, right? So instead of going up by 10, here we're going up by a whole nother power of 10. So we're going up by hundreds in this section. Instead of going by 20s, we're going up by a whole nother power of 10. So we're going up by 200s. So working our way up here. So we got 1,000. We're going to go up 10 spaces just like we did at the bottom. So up 10 spaces would be 2,000. Up 10 more spaces is 3,000. Up 10 more spaces is 4,000. Up 10 more spaces is 5,000. And this is our center point again. I guess I could do it in this blue to make it match our color scheme. This is our midpoint. Just like our midpoint here was 500, our midpoint here is 5,000. And now we're going up 5 spaces because we're going up by 200 to get to 6,000, 7,000, 8,000, 9,000. So each line down here is worth 100. So we got 1,100, 1,200, 1,300, 1,400, 1,500, all the way up to 2,000, and so forth. That is the pattern here. Here our pattern is 200, so we go up one spot, it's 5,200. Up another is 5,400, 5,600, 5,800, 6,000, and then repeating. So now we got our final third, and the same thing, we're going up by a power of 10 again. So we're going to end at 100,000, which is just one more zero than we had here. Our halfway point is right here. Halfway between 10,000 and 100,000 is 50,000. Okay. We're still going to have the same pattern we have for this section. So we goes tens, hundreds. Now we're going up by thousands. All right, 20s, 200s, 2,000s. So looking on this side here, we got 10,000. They don't focus in very good, does it? 20,000, 30,000, 40,000, 60, 70, 80, 90. As we go up, we're going 10,000. Now we're going up by 1,000, so 11,000, 12,000, 13,000, 14,000, 15,000, all the way to 20 and 30 and 50. And then when we get to here, we're going up by 2,000s now. 52,000, 54,000, 56,000, 58,000, 6,000, 60,000, 62, 64, 66, 68, 70, 72, right? So we have set up our graph. We are ready to continue. We are going to now make a standard curve using our data, and then we will use the standard curve to find the answers to how large of our base pairs are, and that will be in part 3. So continue on to part 3. If you would like to see how to set up the standard curve from our graph, make a graph that looks similar to this. Exactly. And then use that graph to find the size of our missing fragments or unknown fragments.